Hello everybody, here's a quick explanation of dot product and then some help with question 8 from chapter 3 of Halliday, Resnick and Walker, Fundamentals of Physics, chapter 3, 8th edition. We're going to start that one over. Hello everybody, welcome to the channel, and this is going to be a brief explanation of dot product and one way of calculating the dot product and looking at it, and then some help with Chapter 3, Question 8 from Fundamentals of Physics, 8th edition by Halliday, Resnick and Walker. So, dot product. When you hear product, we usually think about multiplication, which that's how we're taught, right? The product of two numbers, like the product of 3 and 5 is 15. But when you hear dot product and cross product, there is multiplication involved, but it's better to think more of it as a way of combining two quantities. Because it's not strictly multiplication. It's a process. It's a way of combining. And in particular, it's a way of combining vectors. A vector has the magnitude and it has the direction. And so, how do you multiply direction? What do you do with that if you were to just multiply? But that's the thing, is it's not just multiplication. It's a way of combining these two vectors, these two quantities. And so, the formula for dot product here, this would be, A dot B. And the way that we would write this is, the formula A, so the magnitude of A times the magnitude of B times cosine of theta, where theta, of course, is the angle between the two vectors. And the way you get the angle, this is important, is if you put the ends of the two vectors together and then take the angle between them. So wherever the vectors are, they may be in different places, but if you were to put the tails of the two vectors together in the same point, right, in the same location, the angle between the two vectors at that point. Okay, and so if we just multiply those three, now notice we've got three magnitudes basically that we're multiplying. A times B times cosine of theta. Now keep in mind the commutative property of multiplication. When we're multiplying things, we can multiply in any order. For the dot product, you can take the magnitude of A and multiply it by cosine of theta. Or you can take the magnitude of B and multiply it by cosine of theta. Do that first and then multiply by the other thing later if you want. So conceptually, look at it this way. B cosine theta, what are we doing here? We're taking B. So what would cosine of theta times B be? Really, we're taking B, treating it like it's like a right triangle. And then this new thing here at the bottom, this would be B cosine of theta, right? Because B is the magnitude of the whole hypotenuse. And so what we're doing is we're kind of imagining that we're projecting one vector onto the other. And you could do this the other way too. It's just right now it's easier to project B onto A. But you imagine like a spotlight directly above B shining down on it, and it's creating B cosine theta. So we're multiplying this magnitude with this magnitude. Realize too, this is important, that the product, the result that we get, is not a vector. It's a scalar. So the dot product is sometimes called the scalar product because it's not giving us a new vector. So when we get that number, whatever it is, it's not that number to the right. It's just that new number, and then that's it. Okay. So with that in mind, let's take a look at Chapter 3, Question 8. The first question is asking which of those four vectors have the same dot product with A. Okay. Well, if we think of it in terms of A, B cosine theta, A, C cosine theta, etc., which of these have the same projection onto A? If we look at B, right, if we project B onto A, so kind of make the right triangle with B, notice that this B cosine theta, if we want to call it that here, right, B cosine theta for this thing, if we do this also for C, we're going to get the same result. Right, and I've tried to copy this accurately from the textbook. But B cosine theta and C cosine theta are both going to give you this same arrow. And so that means that vector B and vector C are both going to give you the same dot product when dot producted with A. Okay, so the answer to A would be B and C, but then also D and E are going to do the same thing. D and E both would give you, right, if we were to take the projection of D, so D cosine theta would give you this projection onto vector A. And then E would give you that same projection onto A. And so that same projection times A, the same magnitude of A, is going to give you the same result. Now notice here that D and E, their projection is different from projection B and C because they're going in opposite directions. And that's going to matter because of what it is, it's the angle that they're making with A. Okay, so the answer to A, question lowercase a, is that B and C give you the same dot product with A, and D and E give you the same dot product with A also. To answer the next question, it says, which will have a negative dot product with A. We're going to redraw this, and I'm going to take advantage of the technology here to move vector A so that it's lined up, the tail of A is lined up with the tails of the other vectors. Okay, and so keep in mind, again, what's the formula for dot product? It's A dot B is, draw these little arrows, right? A, B, the magnitudes, cosine of theta. So don't forget cosine, don't forget your unit circle, right? Beautiful unit circle, and it's very helpful in this case. So what would make this to be negative? What would give that a negative value? Well, if theta was more than 90 degrees. If theta is more than 90 degrees, or rather, I should say between 90 and 270 degrees, right? Or between pi over 2 and 3 pi over 2, if you're working in radians. That's what's going to make cosine of theta, that quantity, negative. So B, this angle here to B is acute. So A dot B is going to give us a positive result. But A dot D, so now the angle between A and D here, they're giving you the angle theta. But the one that matters for when you're taking the dot product is going to be this angle from A all the way to D. That is more than 90 degrees. And so, in the unit circle, that would put you in the negative range for the horizontal value, the cosine value. And so D is going to give you a negative dot product. Same thing for E, right? Going around, getting to E, either from here or even if you go the other way, from here, right? That's going to end up giving you something between pi over 2 and 3 pi over 2. It's putting you in the negative side of the unit circle for the cosine value, right, for the horizontal value. And so that is also going to give you a negative value for the dot product. And then C is within 90 degrees, and so that's not going to give you a negative value. So D and E, this is the answer, D and E give you a negative dot product with A, because again, when you think of like D cosine theta or E cosine theta, the theta for each of those, when you take the cosine of it, gives you a negative value. Okay, so hope that helped. If you have other questions, put them in the comments below. Check out the other resources at the channel. Don't forget to like and subscribe.